Hello everyone. Welcome to today's webinar titled Toward Web App and API Security, Why Your Conventional WAFs No Longer Cut It. I would like to thank you for making time to join us today. My name is Tai Ibn Zabuahini. I'm a technical support engineer here at WAAP. I will be your host for today. I would like to bring to your notice that this webinar is being recorded and will be uploaded on our YouTube channel. You can send in your queries in the chat and we will try to answer them at the end of this session. For specific additional queries, kindly leave us an email at marketing@montaapp.com. And for technical queries, please shoot us an email at tech_support@montaapp.com. Before we proceed, I would like to seize this opportunity to briefly introduce WAAP to you. WAAP is a security vendor that has been researching and developing industry-leading application acceleration and security technologies a little over 20 years now. We are a public company listed on KOSDAQ, the Korean stock market. Headquartered in Seoul, South Korea, we currently have 2 overseas branches, one in Japan and the other in the US. We are a B2B cybersecurity technology vendor with a catalog of layer 7 security technologies. Depending on where your applications are deployed, the services needed, how you want to manage them, the level of architectural flexibility and performance you require, or for even share compliance, we have a technology in our catalog that meets your requirements. We deliver these solutions in 3 different ways. We have the hardware appliance, we have the virtual appliance, which comes readily available on AWS and Azure marketplaces, and we have the cloud-based service through our Ion Cloud platform. We also have a CTI lab called the AI Labs, which is a machine learning-based cyber threat intelligence platform with real-time threat intelligence on attack vectors, IP reputation, URL reputation, and the likes. AI Lab is quite actionable and timely such that it's being used by Google's own VirusTotal. Currently, we have 25 overseas partners, 40 points of presence across 15 different countries. Note that this is where we are at the moment, but we are rapidly expanding. We have thousands of clients across different areas of industry, both domestic and overseas. These clients include service providers, financial and government departments. These are just a few of the big names which I believe you are familiar with. Some of them, of course. With that out of the way, let's proceed with the agenda of the day. We will take a look at why not the WAF. We shall also look at an overview and some key features of the AI WAF. And to conclude, we'll have a review and a question section. Let's dive in. Why not WAF? Which also implicitly answers why WAP? Well, the days of predefined rules for signature-based, pattern-based detections aren't over, but are not adequate in today's rapidly changing cyberspace. The legacy WAF relies on predefined rules to detect and block attacks like SQL injection, cross-site scripting, etc., which are not effective against API, bot, and DDoS attacks. It is therefore imperative to have an integrated WAF solution capable of mitigating these attacks. According to Gartner, by 2026, 40% of organizations will choose a WAF provider based on how advanced their web applications and API security features are. Let's take a look at why the industry is marching towards WAP in the following slides. Now, with the increasing adoption of cloud technology, enterprises have carved out business models around the cloud. According to IndusFace, an average of 364 applications are deployed by enterprises with an average of 100 million API calls daily. It is not surprising that API traffic accounted for more than half of all global HTTP traffic in 2024. In tandem, web and API attacks rose by nearly 49% in the last 18 months, according to Akamai. API-specific attacks reached 108 billion. According to Casada, 44% of account takeover attacks specifically targeted API endpoints, highlighting the increased vulnerability of APIs to automated threats. For the first time in 10 years, bot activities surpass human activities on the web, accounting for 51% of web traffic. Out of this percentage, 14% is good bots, like your search engine crawlers. The remaining percentage are deemed malicious. In general, bad bots have lots of negative impacts. Aside the DDoS, web scraping, carding attacks, etc., there are huge financial implications. According to Casada, a staggering 96% of organizations reported losing revenue to malicious bot attacks in the past year. Notably, 38% of these organizations estimated that a single bot attack cost them $500,000. With complex bots that mimic human mouse movements, spoof browser fingerprints, and circumvent basic bot mitigation technologies, the need for similarly powerful bot detection and mitigation systems has never been more pressing. According to Cloudflare and Google, the total DDoS attacks increased by 70% year over year. Over 35% of organizations reported being targeted by a DDoS attack last year. From the chart, Layer 7 DOS attacks are growing nearly 2 times faster than Layer 3 and Layer 4 attacks due to API abuse, botnets mimicking human interaction, harder detection at the application level. According to the same sources, 70% of attacks cause outages lasting more than 30 minutes, with an average cost of $20,000 to $40,000 per hour. Now, the primary focus of traditional WAFs is to protect web applications. Traditional WAFs do not do well at protecting API and mitigating bot or DDoS attacks. At this point of the webinar, you should have 2 answers. 1, why not WAF? Let's summarize it in the next slide. For adequate web security, the industry is moving towards the WAP due to these 4 main categories or modules. The WAF only takes care of web security. However, it is imperative to have an integrated system that takes care of API security, bot mitigation, and DDoS mitigation also. Now that we know why we need the WAP, let's take a look at what the AI WAF offers. AI WAF is an integrated web application firewall which comes in both hardware and virtual appliance, designed to secure web applications and APIs. The AI WAF achieves WAP requirements with its 4 main security modules. We have the WAF, we have API security, we have bot mitigation, and we have DDoS mitigation. Let's take a closer look at what these modules contain. Let's take a closer look into these modules to look at some common attack types the AI WAF protects against. So as you can see in the diagram, we have DDoS attacks, both layer 7 and layer 3 and 4. We also have web application attacks, which our WAF takes care of with the WAAP's top 10 web vulnerabilities. We also have API attacks, same thing, WAAP's top 10 API vulnerabilities. We have bot attacks, where we have application profiling and threshold detections to take care of these. And we also have zero-day attacks, where our in-house CTI comes in play. Now, though the AI WAF can provide some level of protection against layer 3 and layer 4 DDoS attacks, it's worth noting that its primary focus is on layer 7 DDoS attacks, which accounts for 65% of all DDoS attacks. The AI WAF is integrated with our machine learning-based cyber threat intelligence platform called AI Labs, which collects raw threat intelligence across multiple sources. Then we run our ML algorithms on them to formulate signatures and patterns and algorithms to proactively mitigate evolving threats, including 0 days. So here you have your diagram, and you have the integration, an illustration of the integration of the AI Labs with the AI WAF. If you would like to know more about our CTI, log on to ailabs.monitorapp.com. Now, let's take notice of the 3 takeaways of the AI WAF. The AI WAF provides essential WAF features. You also get world-class proxy technology with minimized latency and advanced threat response through the integration of our CTI. And you also get consistent security across on-premises, public and private clouds. Now let's take a look at the features of the AI WAF. Now before I proceed, I want to paint a picture of traffic stream in a web request and response communication. Traditionally, after a successful TCP 3-way handshake, you have a client encrypting data or traffic and sending it through to the web server. And once the web server decrypts, it also responds with the information during the handshake. Notice here that if there are malicious packets in the traffic, it gets to the web server and they are being executed. Now, juxtaposing the previous diagram to this one, the AI WAF sits in the middle of the client-server connection, decrypting, inspecting, and encrypting web traffic, detecting, blocking, or rejecting malicious packets per the configurations deployed. To be able to do this, the AI WAF needs a copy of your TLS certificate that usually sits on the application server. Now, once you are done with that, you get access to all the features of the AI WAF. Now, the AI WAF has several granular policies with easy configurations. So, the image you are seeing here is our domain policy, where you can configure granular policies for your domains, which also takes care of the WAAP's top 10 web vulnerabilities. You can easily configure HTTP request and response rules, URL authentication, domain-specific security rules. Now, I guess the image is smaller, so you don't get to see the policies. Let's take a closer look at the domain policies in the next slide. So as you can see, we have 8 different groupings of the policies. We have the vulnerability attack detection, which basically is your WAFs top 10 and more. We have your user-defined detection, where users can specifically create their own rules for specific domains. We have threshold-based security policies, and these come in handy when you are looking to block bot attacks and DDoS. You also have group block page settings, where you can create groups from different IPs or multiple URLs and customize your block page to communicate with those trying to go against the policies you've created on the WAF. We also have the web's accelerator policy, and this basically is a caching policy that helps with latency. You have the abnormal request and response. You also have the server data protection, which helps with DLP, your error cloaking and header cloaking. Last but not the least, we have the WebSocket detection, which helps you mitigate against malicious WebSockets. The AI WAF protects not only against WAFs top 10 web vulnerabilities like I mentioned, we also have features that work to protect against anti-defacement, WebSockets, and DLP. Now, our caching feature allows for flexible TTL configurations. The next feature we want to take a look at is our API security module. Now, the AI WAF takes care of the OWASP top 10 API vulnerabilities. You can easily add an API schema file or specify an external server URL of the API you want to protect. This way, you can control them better by setting access control with method validation. You can also do upload control, allowing only specific extensions to be uploaded. You can do header control with specific headers allowed. If you are using JSON Web Tokens, you can also do a number of things on your JWT. Now, you can set JSON Web Token signature control. You can also do JSON Web Token payload checks based on parameter, cookie, or headers. You can also do role-based access control with custom claims. How many APIs do you have? I mean, how many APIs do your company have? Do you know exactly how many? What about the shadow IT APIs being intentionally hidden from you? Now, the AI WAF automatically identifies API endpoints and detects the hidden shadow and zombie APIs, effectively eliminating a phenomenon of API straw, where companies have so many APIs that they are not aware of all of them and even neglect to keep them up to date. And in the diagram, you see how the AI WAF does that. Let me rehash this, that our AI WAF is integrated with our CTI labs, the AI labs. And the AI WAF constantly receives threat intelligence such as IP and URL reputation, command and control IPs, blacklisted IPs, and the likes, effectively enabling the AI WAF to proactively respond to evolving threats including the 0 days. So as you can see in the diagram, we illustrate how the AI WAF fetches threat intelligence data from multiple sources on the internet. We run our machine learning algorithms on them. We generate patterns, signatures, and algorithms, and we push it to the AI WAF. Next feature I want to take a look at is API and application profiling. This uses machine learning to learn what is normal traffic to help the AI WAF determine behavioral patterns of malicious traffic. Now, API and application profiling coupled with threshold policies, the AI WAF mitigates common attacks like HTTP request flooding, credential stuffing, to mitigate bot and DDoS attacks. Application profiling learns based on these functions: the method, the host, the path, profile attributes, and the like. The AI WAF inspects traffic and blocks injected malicious codes in real time. You can also verify in advance whether security policies detect new vulnerabilities by using the policy testing feature in the AI WAF. Now, whilst testing your security policies in advance, logs are being generated for auditing, which can be found in the detect logs, just like the real logs. Also, the AI WAF automatically converts complex web addresses into simple format to enhance readability and search engine friendliness. As you can see in the table below, you have a before and after. So you see how easier it is after the conversion. The AI WAF also has a feature where you can configure URL access control, effectively requiring authentication to specific parts on your web server. You can also block specific URLs by rewriting URL calls to specific error pages, example 403 or 404 error pages, effectively blocking calls or access to those specific paths. You can also protect internal server resources by encrypting sensitive URLs in the web path, effectively hiding them from potential attacks. Bots and DDoS attacks have evolved significantly. Originally, these attacks last longer days. But to evade detection, the duration has significantly reduced to mimic human browser patterns, roughly from 10 minutes to 1 hour. Threshold-based detection coupled with application profiling comes in handy in mitigating these behavioral attacks. The AI WAF also has a capture trigger for exceeded threshold with specific time duration. As you can see in the diagram, this is the configuration page for HTTP request flooding detection. We have multiple configurations for click fraud, login attempts, and other bots and DDoS behavioral patterns. The AI WAF supports shared multi-tenancy, which allows different web applications to run concurrently in isolation. This allows specific security rules to be configured for separate domains with complete data isolation and quality of service based on bandwidth control. Now, what this means is you can have multiple applications on your AI WAF and be able to configure specific security rules for only specific applications. The AI WAF also supports HTTP2, providing performance improvements to users, eliminating the complexities and potential vulnerabilities associated with it. The AI WAF handles these complexities by acting as a reverse proxy, terminating the HTTP2 connection and translating it to HTTP 1.1 before analysis, and then forwarding it to the back-end servers. This allows AI WAF to inspect traffic for malicious activity and still deliver the performance advantages of the HTTP2 protocol. Now, on the diagram here, you can see when you add in the server certificates, you can configure whether to allow HTTP2 support or not. The AI WAF also easily integrates with third-party SIEMs to forward pre-normalized system logs. This helps with centralized network incident monitoring and management. So as you can see in the diagram, this is the configuration console of the SIEM integration. We support UDP, TCP, and TLS protocols. Now you have pre-normalized logs that can be easily forwarded to your SIEMs. The AI WAF also has a dedicated separate web console for troubleshooting. The core services of the AI WAF can be set to debug and delegate logs like TCP dump and specific critical information can be gathered for general troubleshooting. You can gather logs or dumps for specific ports as depicted in the image on your screens. With the Advanced Threat Analysis add-on, the AI WAF blocks malicious files and can keep copies for auditing purposes. You can also perform antivirus scans, static and dynamic analysis, automated reverse engineering, and many more. So as you can see in the diagram, this is the malicious file analysis solution interworking interface, where you add your API of your advanced threat protection interworking system solution to the AI WAF, and you get to do the configurations mentioned earlier. Now, let's refresh our minds on what we've covered so far. The AI WAF comes in a hardware appliance, also comes in a virtual appliance, which is available on AWS and Azure marketplaces. The AI WAF meets WAP requirements with our integrated WAF, API security, bot mitigation, and layer 7 DDoS mitigation modules. We also have integrated machine learning-based cyber threat intelligence platform for proactive protection against attacks and 0 days. You can easily integrate a SIEM into the AI WAF for system log forwarding. We also have a dedicated appliance management interface for troubleshooting. We have granular multi-tenant domain policies with quality of service control based on bandwidth. The AI WAF also supports integration with advanced threat monitoring, which comes as an add-on, and with our application and API profiling, coupled with threshold detection, The AI WAF mitigates against bot and DDoS attacks. This brings us to the end of our webinar today. Thank you for joining.